Hello everyone, today we will be looking at a process improvement sequencing problem. So let's get to it. High quality hairstyling and physical relaxation services at a reasonable price. The service process includes 5 activities in the sequence. Activity 1, welcoming the guests and offer homemade herb tea, 13 minutes. Activity 2, wash and condition hair, 9 minutes. Activity 3, neck, shoulder, and back stress release massage, 6 minutes. Activity 4, design and hairstyle and do the hair, 24 minutes. Activity 5, check out the guest, 5 minutes. So there's 3 servers that offer the services in a work or paced line. The assignment of tasks to the servers is the following. Server 1 does activity 1, server 2 does activities 2 and 3, server 3 does activities 4 and 5. Business has unlimited demand. So they're going to ask us 4 questions. So the first one is, what is the labor content in minutes per customer? So the labor content is the total amount of work that goes into one unit. So theoretically, you just add all the tasks together. But how we're going to do it is we're going to calculate how much time each server works on the tasks per unit, because it's going to help us find additional information for the future of the problem. So server 1, we know that server 1 does activity 1, just 13 minutes long. Server 2 does activities 2 and 3, so that's 9 minutes plus 6 minutes. So 9 plus 6, 15 minutes. Server 3 does activities 4 and 5, which is 24 minutes, 25 minutes. So when you look into process improvement or sequencing, even if you're not asked directly, it's always good to find the bottleneck. And the bottleneck is the task or the resource that takes the longest. So in our situation, it would be server 3 is the bottleneck at 29 minutes because they're holding up the entire process. Generally, if you're looking into process improvement, at your workplace or your personal life, a good way to find a improvement in a process is to reduce the amount of time the bottleneck takes. But going away from that little tangent, back to labor content, now we would just add all of the tasks together, and that would give us a labor content of 57 minutes per customer. And I'll highlight it for your reference. So the second problem is what is the average labor utilization in percentage? So labor utilization is the labor content divided by the labor content plus idle time. So we found the labor content in the last problem, 57 minutes, and now we have to find the idle time. So the idle time is the bottleneck minus the task time. So what the idle time finds is essentially it lets you know how much time your resources are doing nothing and not being productive. So ideally, you'd want the idle time to be low as possible if you're trying to have an efficient process. So server 1's idle time, since 29 is the bottleneck, you would do 29 minus the 13 minutes that they take per unit. You would do the same thing with server number 2. And then in server number 3, since it's the bottleneck, it's going to be 0. 29 minus 29. So now that we have the idle times of the resources, now we know the total idle time. Total idle time, you would just add these 3 together. So I'll put that here for your reference, total idle, and you would get the sum of these 3. And it's going to give you 30 minutes total idle. So now for labor utilization, we just do the labor content divided by the labor content again, plus your total idle time. And that'll get us 65.5% labor utilization. This means that our employees are only 65% efficient as they could be. So if you have a business or a process, you want this to be as close to 100% as possible, because the closer it is to 100%, that lets you know that your workers are busy and being productive. So the third question they ask is, at a wage rate of $15 per hour, what is the cost of direct labor per customer? So the direct cost of labor, how you would find that is it's the total wages divided by the capacity of the process. So because we have 3 servers, they're getting paid $15 an hour. Our total wages per hour be $15 times the 3 servers. That's $45 an hour. The capacity is going to be 60 minutes in an hour divided by our bottleneck. And that lets us know how many units go through the process in an hour. So with how the process is right now, it's 2.06 units in an hour that go through the process. So the direct labor cost per unit is going to be your total wages divided by your capacity. And it's going to be $21.71 direct labor cost per unit. That's how much it costs of labor to produce each unit. Problem number 4, the owner considers hiring a new employee to help with one of the servers without changing the tasks performed by each server. So what would the new direct labor cost be? So since we're adding a new employee, now there's 4 employees in total. So you would multiply that by the $15 wage, and now your total wages are $60 an hour. As I mentioned earlier, in the very beginning, with processes, typically you want to improve the bottleneck, and by doing that, you'll improve the process as a whole. So if you're getting a new employee, you'd want to apply that employee to the bottleneck. So the bottleneck was previously 29 minutes. If you add the new employee, you would just divide that by 2, because now 2 people are working on it. So your new bottleneck would be 14.5 minutes, which is a huge improvement of what it was before. So now with the new bottleneck, we have a new capacity. So we do the same thing as we did last time, 60 minutes in an hour divided by 14.5 minutes, which is the new bottleneck. And now instead of getting a little bit over, 2 units per hour, we're getting a little bit more than 4 units per hour, which is double than before. So direct labor cost per unit be your total wages, divide that by the capacity, $14.50 cost per unit. So by adding a resource, we just did about $7 better. And that is the process improvement sequencing problem. I hope you enjoyed, and thank you very, very much.